All right, good morning, everyone. Welcome to our weekly Subspace protocol, backend protocol sync meeting. Today, Ozgun is going to give us some updates on the GPU plotting and an article he's writing. Nazar is going to give us a detailed update on the upgrade to Subspace v1 consensus. And Serge is going to discuss some changes to the relayer backend. Okay, without further ado, Ozgun, why don't you go ahead and take it away, please?
Yeah, sure. So article is mainly done, tentatively. So the template is ready. I left the introduction to you, Jeremiah. This is going to be written, and then the background. And for my parts, slot introduction is done. And then acceleration on the CPU for slot is also done. Thoroughly. And also slot acceleration on the GPU part is done. And also, as a summary and the conclusion, the published library slot 256.189 is written. And also review of the final results is written. Do you want me to share my screen, or should we save it for as a surprise? I don't know.
Why don't you drop the link in the chat? So Serge and Nazar have a link to it, and they can look at it on their own.
Sure.
I haven't had a chance to review it. That it's going to take a little while to go through that and give feedback. So I think that's a little bit outside the scope of the call. But thanks for an update on that. I'm glad to hear that you've made a lot of progress on that. Can you give I know there's been some changes, but can you just give us an update on what's happened with the GPU code since the last protocol sync?
Nothing. It's working, so nothing has been changed. The only thing that changed is on the slot 256.189's documentations and readmes. So code-wise, nothing has changed.
Okay. Can you give us a quick overview of that?
The updated readmes and documentations?
Sure. Yeah. If you could just pull it up, I don't think that's something we need to go through commit by commit, but if you can just pull it up and give us an orientation as to what you did there.
I'm going to share the screen.
Show us what's new. If you go to the current master or whatever the commit you had was.
Okay. So right now in this repo, this one, the README is updated. So right now it says there are two major implementations, and this was already present. So I added this part and that part, and I'm not diving into the details of this. So I'm referring the people to these files for the specifics of CPU and GPU. And when we move to there, let's go source. Let's start with CPU. So there is this README, which explains what is going on in the CPU implementation in a high level. And if we want to dive in further, there is also documentation.md. And in here, all the code, nearly all the code, is documented. So this is a long file, and it explains all the nifty details of what is going on in the algorithm itself. And other than that, let's move to the CUDA. And in here, there's also README. So this explains what these three main files are doing, and then why GPU is efficient in our case. And also, there's a link to supranationals report, the estimation of performance, both theoretical and practical. And also, it says that CUDA implementation is not that different than the CPU one. It's actually following the same base algorithm. And for these, you can also refer to the README and documentation in CPU. And if we open that, this is a PDF. So it's just the report that supranational gave us. So these are the changes in the repo. Other than that, there is nothing going on code-wise on my side. I'm just busy writing the article.
Cool. If you can go back to that,
Yeah.
Ozgun.
Yeah.
Any place that you've got, like if you scroll down, you've got a bunch of things where you say go here. If you can make those into hyperlinks,
Yeah,
that
I can do so.
just
Yeah.
makes it really, really, really easy for the user.
Yeah, sure.
Yeah, thank you. But otherwise, it looks great. That's an excellent overview. That's exactly the kind of high-level documentation that I was looking for, and that I think we really need to have across the project. So great job.
Thank you. No problem. Let me share the screen. All right.
Okay, so can you just give us like a 1-minute summary on where we stopped with the GPU and what you foresee the next steps to be?
Okay, currently our implementation for CUDA is very efficient in my opinion because it uses PTX. Maybe it can be tweaked further with making it more branchless. There is still some small room to do that. Other than that, I don't think it will be 2 or 3 times faster than its current version. The next most important step should be, I believe, the OpenCL implementation for GPU to support AMD ones. And after that, I think we will cover every GPU model. And I think it will be 90 or 95% done for the GPU work. The leftovers would be to further improve and tweak the algorithms. But again, as I said, it will be like maybe 1% or 5% improvements, in my opinion. And I think we will just maintain it throughout this protocol. Other than that, I don't see much to do in GPU part.
Okay. How much of that is captured on the board in discrete tickets, at least high-level tickets that say the name of the task? They don't need to go into the details of how to execute it.
I think none. Like CUDA progress in detail is completely ticketed and on the boards, but OpenCL and further improvements are not. Actually, further implementations or improvements for CUDA is ticketed, but nothing related to OpenCL is present.
Okay. Can you just, after this call, can you just go through and make one final pass at the board in terms of the backlog and just try to capture what you see as the next major steps? Include any to-dos that you had left over in the code, any optimizations that you can think about, anything to make it more cross-platform on the CUDA side. We don't need to worry about OpenCL right now, because we're about to start a contract on that. Hopefully, we're going to be signing that this week. But yeah, let's just capture everything, because at some point we're going to have the time to come back to this, and then we're going to be like, oh, what did we need to do? And then we're going to have forgotten all that we need to do. So let's just try to capture the high-level tasks for this. Okay.
Sure. Do you want me to do that in GPU plotters page, or there is a more common or general board, as I believe? Should I do it in there?
Let's do it in GPU plotter, because I think the protocol board's going to get pretty heavy with some other tasks here soon.
All right, understood.
If it's something that's specific to like sloth 256189 or the algorithm or something like that, we can put it in protocol board. But if it's just the GPU implementation, let's leave that in the GPU board.
Okay.
Okay. Any questions or comments for Ozgun? All right. Okay, thanks a lot for the update, Ozgun. I will try to look at the article today. It might realistically be tomorrow before I get a chance to do that, but I'm hoping by the end of the week we can have that closed out.
I think you should do tomorrow, because tonight I will just review it by myself, so it will be more ready for you on tomorrow.
Okay, sure. Just shoot me a message whenever it's at that point.
Yeah, will do.
Great. Okay, let's switch gears. Nazar, if you want to show us what you've been doing on the Subspace protocol.
Absolutely. I think this is the right window.
Your audio is kind of low again, Nazar. I don't know if it's that way for everyone else, but you get a lot quieter when it switches to you.
I could make it much louder. Is it better? Or not?
Yeah, that's better.
I'm just afraid it will be clipping. Maybe I'm just talking quietly. Can you see it?
Yes.
Should I make it bigger?
Maybe a little. There you go. That's better.
Okay, so I just want to quickly start with cross-platform fixes. Does everyone understand what's going on here and why? Okay, so the basic problem was that there are certain features like assembly in SHA-2 and SIMD instruction acceleration in the erasure code library that we need ideally to enable on platforms that support them. That speeds things up quite a bit. However, it's not supported everywhere. So I had to write this like strange conditional here and here that only selects specific platforms where it's supported. And the main problem is that there is this ticket, upstream ticket, that basically talks about having features that are target specific. And it's not implemented yet. It's been like from 2015, so it's not going to happen very soon. But we can actually like have the whole like separate section basically for every platform. So instead of having features which are per platform, we have like the whole bundle per platform. So that's why we have this copy paste. But other than that, this allows us to have M1 and Windows with the MSVC compiler and everything working just fine. So this was the fix for cross-platform support. Subspace upgrade step 10. There was basically a preparation before everything else. I think we can go through the whole thing at once. This is just import change. Yeah, so okay, let me go through commits then. So this was switch from async SCD to Tokyo in some places. Basically, the latest update from the JSON RPC library that we are using here as a client changed its implementation from async standard to Tokyo in one of the release candidates of the 0.2 version, I believe. So we effectively have Tokyo right now. So it doesn't make sense to have two runtimes, which is why I was switching from async standard to Tokyo. Not in all places yet, but in most places.
Can I ask a question on that?
Sure.
Like, is Tokyo more efficient than async, or is it just for our case, or any opinions on that?
My opinion is that Tokyo is generally faster. Like in absolute sense, I think. It might not be very significant for many of practical use cases. And actually, like in the library the libraries that I wrote, I really prefer to use underlying libraries from async standard. So at some point, async standard actually changed their executor, I believe, to small. And small itself was a very small runtime built by Stepan Glavina. And that runtime itself was later split into multiple different crates. So you have lots of pieces like IO reactor, you have the scheduler for runtime separately, and you have like all of these pieces. And it's much more convenient for me to assemble all of those like global level pieces instead of pulling the whole async standard, which has lots of dependencies. So I prefer that, but Tokyo is basically de facto standard. And the async standard is it appeared later in the ecosystem, and it's I think a bit less popular, but it's a good option nevertheless. It's just that runtimes usually, like if you have a library, it's usually tied to some runtime, and if you have that runtime, it's doesn't make a lot of sense to have two runtimes basically. Yeah. This is just some refactoring, doesn't matter, I think. Oh yeah, so I basically had this function which was farm, and it was a pretty long function. And since I wanted to add more functionality to it, I basically moved some of the functionality into a separate function, such that those functions can be run and tested independently, and we can have more stuff in this like main farm kind of wrapper function. So this was the change. Useless awaits. This is again some refactoring. JSON RPC update, new RPC endpoint on the farmer. So we need to have some of the information about protocol configuration on the farmer. And for that, I've built another RPC endpoint, which basically returns this farmer metadata data structure, which has confirmation depth, record size, and other things that are necessary for farmer to instantiate the archiver and handle everything accordingly. And yeah, there was a pull request about a bunch of cleanups, which is not useful to go through, I think. The big one is this step 11, which is basically the first pull request in which the subspace consensus is introduced. It's relatively big, and there are still some edge cases which I'm trying to iron out. That's why it's in draft. So the first step was to prepare for the fact that we will have plotting done in the background. So there is no separate plotting process anymore. You just start a node, start the farmer, it will try to plot in the background, and it will try to solve on whatever is already plotted. So like for every single request, you will be using increasing plot size. But it's not like you cannot solve until you plot anymore. So for that, I had to add dependency on Subspace archiver, and then I did some changes to the what is this? To the farm function. Basically, I've added the way to request metadata from the node, and then created this background task, which will be plotting. There is some basic implementation of that. So it is a two-step process. We have some pre-genesis information and we have some post-genesis information, basically. And for pre-genesis, we just have a loop which goes through the number of objects we need to create. We generate those objects, we add them to the plot, to the object archiver, we plot those pieces. It's not implemented yet as of this commit. And then separately, we will have subscription to the node, which will receive notification about new blocks being produced, and we will fetch those blocks in full and plot them as well. This is just a small preparation commit.
Question, Nazar. So does the farmer? I know the farmer does the pre-genesis plotting itself, but as new blocks are created, is the client sending the archived erasure code blocks, or is the farmer just getting the blocks and doing it itself now?
Just blocks as is, like binary blobs.
So does that mean that we're like doing all the work twice?
Yes.
Okay. Is that deliberate?
We'll discuss. It's not deliberate. It will be fixed once we have the storage network. We'll be able to fetch pieces from other nodes.
Okay, but those are. Is it not possible to have it use the local plotting for pre-genesis and just getting the subscribing to the archive blocks?
Because you can connect farmer after the network already started, and you have no way to get those pieces which were already produced by the time you joined. They're not stored anywhere, so you need to fetch block 0, block 1, 2, 3, and generate all of those pieces anyway.
Okay, but after you're synced, I mean, for the new blocks, like once you're caught up.
Theoretically, we can switch to that, yes. But
okay.
This is like so additional piece of logic which is not implemented yet.
Okay, so there's like a 3-phase process. There's like pre-genesis plotting, then there's syncing the history, the old blocks and plotting those, and then there's the plotting of the new blocks as they come through. And right now, all 3 of those are done on the farmer, even though the runtime's doing it so it can store the Merkle roots.
Yeah, kind of.
Okay.
Then, as I was doing different updates, I noticed that we have this unfortunate name collision. Basically, we have a segment. Within segment, we have several pieces. And those pieces were indexed by the variable index. But unfortunately, we already have a piece index concept, which is like a global index of a piece within the whole history of the blockchain. So I renamed index within segment to position in every place. So they like very, very different from each other. But it is the same mechanism. So when we are talking about piece within a segment, it's a piece position. If you're talking about global history, it's an index. I'm not sure how clear and useful that is, but at least they're different. So this is
what is it called in the farmer's local storage database? Is that like independent of this?
It's independent. And actually, in this pull request, there is no indexing separate because we are plotting the whole history, so there is no need to map pieces to indices there.
Okay, but we do that later yes, pull request or later. Okay.
Yeah. Then, as commit says, extremely minimal viable product. Basically, what was implemented here is in the farmer. Where is the farmer? In the farmer, there is now an implementation of plotting pre-genesis pieces. So every time we have archived segment from pre-genesis, we compute some variables and we encode everything, and then we store them in our local plot. And this already allows us to run the protocol in Subspace mode, but it doesn't include any of the post-genesis pieces, of course. And there were many updates everywhere. There were some minor changes here. I think there was some data types updates. I renamed Spartan codec to the Subspace codec and changed some data types. I had to comment out some of the CUDA implementation for now because it's not batched in any way right now. It's just a minimum product. And yeah, I had to update a bunch of things related to CUDA. And on the node side, I believe there were some minor updates. Yes, but this is renaming of Subspace codec. On RPC side, we had the nonce in the solution. I renamed that to piece index to make it consistent with everything. And again, the same thing. And verification was updated to check whether decoding actually works, but it didn't check as of this commit whether witness is actually correct for the particular piece. But that was added later. This is like a very, very minimum thing to get it running. And then I implemented the complete validation for the witness on the node side. So there is a new, I believe, what is this? This is runtime API? No. It's just the method to get the Merkle tree root from the storage that we already have. And there is a runtime API for that. And there is like some refactoring to get the necessary information from the runtime API, and then on the, yeah, this is just get variables. Yeah. Just
and these runtime calls are only during startup, like Genesis plotting?
No, these runtime calls are done every time because we need to, we get basically a random piece from the history, and then we need to figure out what is the Merkle root for that particular piece. So that we do call to the runtime to get by index.
Okay, so this isn't for plotting. This is just for verification.
No, this is exactly. This is for
Got
verification.
it. Sorry.
So on the verification side, it looks relatively simple. We just have a few new arguments, and then every time we get to the point where we need to check, we basically call is piece valid. We give it a piece, Merkle root, position within segment, and the record size, and it is able to answer the question. Yeah. There was just a lot of infrastructure to actually get this like Merkle root and handle all the errors and everything. Yeah, and I forgot to mention, I think here we've actually dropped the module for plotting. Yeah. this whole file is gone. We no longer have a separate plotting process. That's why the pull request from Ozgun was rejected. It's no longer relevant. This was a refactoring. It was a little bit changed later, but basically the idea was that we have this somewhat awkward way to drop the plot. This is caused by the fact that we cannot drop. Plot is backed by the RocksDB database, and that database is in C++. It has different notion of constructor. It has like own threads. So basically what we need to do, we need to drop it very carefully at the right time. Otherwise, we will have this strange error with like pure virtual call something, blah, blah, blah. And for that to happen correctly, we had this ceremony where we basically had to subscribe to the, let me show in the other file, in the farm. So we basically had to subscribe to close event and then create a channel to wait for it. And then we had to drop the plot and wait actually when it's actually dropped. So I changed everything such that it will actually drop like synchronously here. That might have a negative side effect when you are dropping it in the asynchronous function. It will actually block the whole runtime. So you might want to do something like this in some cases, but in our case, it's not a problem. And I refactored the plot implementation to actually support that correctly. This is just a usability problem that will be even more severe if we don't handle it like that. Then I created the config struct. The idea was that we have an identity, we have some of the commitments for tags, and we need to store additional information. For instance, for restart support, we need to actually store information about what was the last root block archived with the root block itself. And it wasn't really clear where to put it. I didn't want to create another JSON file, so I thought having a database would be nice. So what I did, I created this config structure, which basically had the method to get a key pair and set a key pair as a basic implementation. And then it was extended later, and then I removed it, and I will show you why. So that was about that. Yeah, then I basically took the logic that we have on the node side and ported over more or less similarly into the farmer, such that we can plot not only pre-genesis pieces, but also post-genesis pieces. We can also support restarts. So we can restart at any point, assuming that our pre-genesis history was plotted fully. And that allows us to run the protocol. No, this is only partial, I believe. Yeah, this is only partial. And then in the second one, there should be implementation for block archiving from the farmer side as well. So on the farm, we have another task, which basically goes through notifications that there is a new block to be archived. And then we try to archive that many blocks one by one, add to the history, and then write to the plot. And here we basically have a subscription for heads. And every time we get a new head, that means we have a new block. We need to calculate minus k deep. And if it's not negative number, we basically have a block that needs to be archived. This is mostly the same logic as we have on the farmer, on the node, but slightly different. And it also handles the case where basically when we start, we may start at the arbitrary point in time. And that might mean that we already have, let's say, 100 blocks on the blockchain, and we are just starting. So this is why we have the, where is it? Blocks archive from. We basically have a request to the archiver itself. It's if it has any storage, if it has what was the last block archived, otherwise we'll get 0. And here we will archive all of the blocks starting from that one to what was received from the RPC. So if you like archived 100 blocks and then we were offline for 300 blocks, then this will be the range that we need to archive when we restart. So this logic is slightly different because of that, comparing to the node. Then I removed the config struct. The idea was that it actually mixes different concerns. So we had, first of all, we had an identity. And then we had a last root block, which like completely different things from one side. And from another side, the identity is actually something that you might want to retain, even if you restart a block or you want to like copy and back it up somewhere. So it's really not convenient when it's somewhere deep within RocksDB database that you cannot access directly. This is why I decided to roll back that change and have it in a separate identity file as before. But I extended the plot implementation to have additional methods for getting and storing last root block, because it really belongs to the plot. It's not some external concept to it. So this was the refactoring because of that.
Just a comment or question on that, Nazar. So would it make sense to have a config file related to the blockchain that's more stored on the client that the farmer can retrieve, and then a separate one just for the keys in the key store, which has like a whole different notion of security?
I do not understand the question, sorry.
So you've got config data, which is about the blockchain, right? That what was the
no
chain
config anymore?
Okay, well, I mean the config data that you had. What aside from the keys, what was in there?
Last root block.
The last root block that was plotted, or that was just seen from the chain?
Last root block that was plotted.
Okay, so I guess that's not really specific to chain city then. Okay, never mind.
Yeah, and then there was this unfortunate side effect of the implementation where we have this rendezvous channel where we are sending blocks that needs to be archived. However, we cannot send another notification until the previous one was read. So if we were archiving something, and imagine it takes like 10 seconds, then it can be such that the notification that we have here, it is sending the block right after the previous one that we've had, but all of the subsequent blocks, they will be like skipped because the channel is blocked for now. So what I did instead, I'm now sending the atomic variable, such that even though this is like working only once and then you have to read the message before you can send another message, we can update the underlying number. So when the reader, this loop that tries to receive the blocks that needs to be archived, when it reads the information about what blocks to archive to, it actually reads the up-to-date value always. There is a comment about that. So this is like a neat trick how to make it have less latency when you receive notifications. Then I moved plot test into separate file and fixed some of the remainders from the config removal that I forgot to clean up. This is no new logic. And I moved that because the plot file is already big and I had to add tests. So I've added some of the simple tests to test that root block methods are actually working properly. Then there was this interesting edge case that I think is partially still there. That's why I'm saying that this is a draft. I didn't quite figure it out. Basically, the problem is that we are using vectors and we are using scale encoding. And scale encoding is using compact representation for numbers for the vector. So if you go to scale codec and we go to documentation about vectors, numbers, compact. So basically, numbers are prefixed with 2 bits that represent the length of the integer. So if it starts with 00, then following 6 bits are the length. so it can store only up to 64 elements. Then if it's 0, 1, that we have 2 bytes, and we can store up to this much. And then we can have 4 bytes in big integer mode. So sometimes it might so happen that we have a vector with 63 elements. 63, 64 elements. But then when we add one more, we not only add the data, we also increase this number from 1 byte to 2 bytes. And that results in an interesting situation where, so here, when we have collected all of the segments, we have this check of what is the spillover. So basically, when we add last element to our segment, we may add more than necessary, so we need to like split the block at some point and only include part of the block, and the rest of the block will come into the next segment. And it so happened that the spillover was bigger than the size of the element that we've just added. And we were trying to get an offset, which was basically like in the minus direction. So it was overflowing the integer and it was causing the problem. So there is a carefully tweaked test, which basically adds enough elements such that the last element basically overflows this situation. But I think there is one more edge case like this, which I need to trace down and fix. You can read, there is like a lot of comments about what is actually happening, why, and why it's important. So there is a comment here, and I believe there is someone somewhere else. Yeah, there is explanation here of what we are testing. So that was an interesting thing to tweak, and then I also tweaked some of the messages just to print what object and what block we are at. And it looks like this. I don't think it's very useful to go through all of the commits one by one, and that will take a long time. However, it's just a little bit concerning that every time I submit a pull request, there is no comments, no questions, which either means the code is so perfect that there is nothing to complain about, which is I don't think is the case, or it's like so unclear that it doesn't really make sense to ask anything. So I think the latter is more correct, probably, and we need to move it somehow into the direction where you actually can meaningfully review all of this.
I think there's two problems. One, I mean, no offense, Ozgun or Serge, I think you guys probably just don't have your head wrapped around the way this thing works well enough to really be able to meaningfully comment. So a lot of the questions would just be asking for re-explanation of things. On my side, I'm reading the code and I'm just trying to understand where you're at, versus being able to comment on, like, you know, critiquing the implementation, the way that you're doing it. Because I've got like 1 hour a day to work on this like code related stuff. So I just don't have the time to go into that much detail. I think once we bring on another protocol engineer, like the one we're talking to, then hopefully we will be able to get more meaningful feedback on these commits. But I think that's just kind of the state that we're at right now.
It's more like I'm writing code, I'm reviewing myself, and it's like I'm alone here, basically. You had some pretty good questions yesterday, but other than that,
yeah,
no one really reviews what I'm writing.
Well, I mean, I'm reading it. I think I'm getting most of it. I mean, I could critique your code. I think it's probably not like, it's a question of like optimization at this point. I mean, I'm looking for things that are like incorrect from a security point of view, but luckily we've done such a good job with Srivatsan on getting the spec written and the diagrams that it should be much more clear, you know, what you're writing now. So like as before, I had to review your code more because it was just like a lot of verbal communication back and forth. But now that we have written guidelines, and as far as I can tell, you're following them. So that's mainly what I'm looking for. You know, is there something which is just incorrect from the point of view of the way the protocol is supposed to work?
And I was doing some minor tweaks to the specification, like around the naming and some of the variables to make sure they match the code. So if you have like a variable in the code, you can Control C, go to the specification, you will probably find that same word in there, which I think is useful.
It is for sure. It saved me a couple of times. So when I'm unsure of anything, I just, as you said, copy paste it, copy and search it on Notion, and it helps a lot.
So this is like the first step. It's not the full implementation. Like it's full implementation in terms of that it works, but there are things like commitment updates and some of the optimizations. There was like a bunch of to-dos here. If you just, I don't know if all of the files are expanded. This isn't. Like if I search to do, I have like 37 matches. So there is still work to be done here.
What would you say are the most critical, I don't know, 3, 4, 5 to-dos that come to mind right now, Nazar?
So I want Salt update the commitments to Salt that we do every time Salt changes that need to really happen for new pieces immediately. So when we plot a new piece, we should be able to use it right away. That would be an interesting update. Later, DSN would be nice, so we can actually collect those pieces from other nodes instead of plotting everything ourselves. I had some of the to-dos here. Yeah, there is no check for different history. So imagine locally you've started the node, you've been testing, plotting for some time, then you restart the node. The farmer will not be able to figure out that this is actually a different node. There is like one check. If you are restarting and it has like reached, I don't know, 400 blocks previously, and you are right now at block 10, it will like refuse to start because this is clearly different history. But other than that, it's not able to differentiate between different chains. Like if it's a completely different history, it will just start producing wrong solutions, basically. So we need to pull some of the information from the chain to actually figure out what version of the history it is, and if it's the same genesis that we started from previously. But that is also slightly tricky. I'm not sure there are timestamps in the blocks. If there are, then probably fine. Otherwise, we'll need to check more carefully what history it is. Then
Quick question on that, Nazar. Are you talking about the case where my node has been shut down and I need to resync the history first and there could be a deep fork, or the case where there's been like a hard fork and a restart of the blockchain from Genesis?
Restart, basically, for development purposes especially. It will be, I think, quite a few times that people will be confused. They will like use TMP flag to run it without storing anything, and then they restart, and it's completely fresh history, and the farmer is like, I don't know what's going on.
Okay, so that's not really a security issue. That's just keeping it in sync for development.
This is like a nice to have feature. You should be able to detect it and maybe like suggest to raise a plot or something like that instead of just doing the wrong thing.
Yeah, I think the easiest thing to do would just be to include like a timestamp in Genesis block and
I'll figure something out. Like there are many to-dos for those kind of things. It's just not implemented yet because I need to get something working. Yeah. Yeah, there are also tests are not working anymore. Some of those that worked before. This is because we have no support for transactions, and those are actually necessary now to be able to process the root block storage and Merkle trees in the runtime storage. So we just lose that ability for now. What we need to do, we need to change our runtime that we use for tests. And actually, we are using the Substrate test runtime and its client. And folks from Parity actually said that they want to get rid of it too. And send me some links to example runtimes that they're using for other projects. So this is, again, something that someone can tackle earlier than me, probably. and that will allow us to unlock some of the tests. I fixed them, like they theoretically work, but we cannot run them, which is unfortunate. So those kind of things. Batching and CUDA support is non-existent for now. Not like that's a problem for development purposes, because we no longer have this separate step of plotting lots of data, but we will. That will be a problem.
Okay. So are you finished with your update, Nazar?
I think so.
Okay. So I have a question on the current status. So let me see if this is correct. So right now we have some pre-genesis data that we create from a seed. So basically 10 root blocks or 10 segments of the history, 10 periods. The farmer plots those 10 periods and immediately starts solving, because plotting is asynchronous now in the background. So we start farming from Genesis, and then as new blocks are created, they're added to the buffer. They eventually get erasure coded and archived, stored in the Merkle, stored in the runtime, the Merkle root. But then the blocks themselves go back to the farmer. The farmer re-erasure codes them, and it adds them to their plot, but it does not make commitments to them until 2 epochs later. So eventually, the plot will effectively increase in size, but it takes a very long time.
The unfortunate side effect of current implementation is that even pre-Genesis pieces are not always available. At least not all of them. Because we might receive a notification about new slot before we've actually plotted those. So it's like, it's racing. You can actually stop the farmer, delete the commitments databases, and start again, and it will continue from previously, and it will regenerate all of the commitments properly and use the whole plot, but this really needs to be fixed.
What was the rationale for making the plotting asynchronous versus just plotting everything up front and then starting to
we don't know what is up front. Like, while we are plotting, the target is moving forward already. It's like a moving target basically all the time.
You mean as to the size of the history?
Maybe. What I'm saying that we might have block production while we are plotting.
Right. So the history can get larger, and we just never know. So we're just continuously trying to catch up, basically.
Yeah. So we don't even like catch up. We just have a generic mechanism which allows us to do it.
Right.
And we are just using that as a universal way to plot everything, regardless of whether it's like old or new.
Is that just easier from an implementation perspective to have it working that way versus to have a notion of like upfront plotting and then after the fact plotting?
Well, yes, and there is really no other way to do it right now. Honestly.
Just because of the strange like setup mode that it's in right now, because we don't have distributed storage and everything. Okay, got it. Okay. So I'm just trying to think of you listed a lot of stuff there. I'm just trying to think of what some immediate next steps should be. So I think, like you said, committing to the new tags incrementally is probably a big one to make the updates to the plot more useful or more correct. I think another one is going to be expanding. So you have support for pre-Genesis data. We just don't have any pre-Genesis data to upload right now, right?
It's tricky. It's tricky because right now it's like a static seed. And if we want to have some actual data, we need some way to specify it. and I didn't really change any CLI flags on this part on the substrate side yet. So I'm not sure how involved it is to actually add like a parameter and make sure that is all the way through the whole thing.
Okay. So if Serge were to like create a file that was just the key value store of all the Kusama blocks, then and we had that file like on disk somewhere, we still wouldn't really be able to use that right now for pre-genesis plotting.
No, but it is meant to be extensible in that regard.
Okay. Okay, and then on the farming side, how is the piece how are the pieces or the encodings tracked, like the storage of them tracked on disk right now?
They're not tracked. Long story short.
They're not. Okay.
So because we are storing the whole history for now, like just sequentially from piece 0 to whatever the latest one is, we just write them sequentially one after another. Where is this file? Just like we had before with Spartan.
Okay.
And
that makes
there is
sense.
a to do about that to add support for actually tracking that here.
Okay. Until we do partial replica farming, we probably don't need that. So what you're saying is if we had an API which was like get a piece, then as long as the farmer knows the beginning offset of its plot, then it can just calculate the offset from the piece index.
Definitely.
Okay, I think that's fine for now.
That's why it's a to-do and not something that was blocking this pull request.
Okay, that makes sense. So if we were to build in if we were to build in like network support for a get piece API, then it would be fairly easy just to add a query for that within the farmer.
Querying the plot would be easy. I think the network itself would be much harder.
Right. Okay. And what about the farmer as a lib? Are we ready to start refactoring it for that?
Probably. It will be quite involved. It will be less involved now, meaning that there is quite a bit of infrastructure that will not change that much, because as you've seen, like lots of things were moved around, and that would cause lots of merge conflicts if we were doing this in parallel. Now I think it might be possible. Yeah, but I don't think I have time for this right now. But if Ozgun wants to tackle it, I can give some high-level description, but he'll have to figure things out on his own. Yeah.
What is your sense of that right now, Ozgun? Is this library making any sense to you?
You mean the whole commits that Nazar prepared?
I mean, do you feel like you have an understanding of how the farmer side, the Spartan farmer, or I guess now Subspace farmer, is actually working under the hood, the structure of it, aside from substrate, just what's happening in the farmer?
Much more compared to 2 weeks ago. So 2 weeks ago, I would say 10 or 15%, and right now I would say 80 or 90%.
Okay, let me explain what I have in mind. So we have many places where we print something like a debug message or warning message to the console. We have some error handling. All of that, I think, should be replaced with some kind of channel and messaging where we can send events. And then those events can be printed to the console, or they can be sent to the front end to display like a warning message somewhere in a nice way. So basically, the whole thing needs to be refactored such that it doesn't interact with the CLI. And it uses this like messaging transport. And then CLI will use that messaging instead of what it uses right now to actually do its job. And then we will have basically we will have 2 crates ideally in the future. One will be something like lib farmer, and the other one will be like desktop farmer and regular CLI farmer. something like that.
Why does the lib need to be refactored to be asynchronous like that to interact with the CLI? Why couldn't it just be synchronous?
What do you mean?
Well, you're saying you want to have like all these channels and message passing,
Yeah.
but couldn't it just be? I mean, couldn't we just make it work the way it does right now? But change it. I guess it seems like it's simpler to me conceptually. Like it just needs to be a lib. Like that would be an optimization on top of that if we did all of this. But is it absolutely necessary to have all of this message passing between the lib and the CLI?
Well, we need message passing such that we can use it in desktop farmer.
Okay.
So that will be the only way to interact with it. Like
okay, so the CLI doesn't.
We have this like debug and warning macros in the code.
Mm-hmm.
So those are just printed to the console. We need to replace those with something. We don't really want to have if statements in all of the places, whether the crate was compiled for library or not. So if we no longer have those warnings in the code, then we need to have them somewhere, and that will be read the message, figure out what message it is. If it's warning, print the warning.
Okay, so this is not really refactoring the way that the farmer works to be more asynchronous. It's just adding in like an asynchronous event notification system into the current architecture that's then exposed through a lib.
Yeah, kind of.
Okay, I guess I misunderstood that you were talking about like refactoring the whole interface of the farmer to be completely async, but I get it.
I don't think I mentioned async at all. I was just mentioning channels.
Well, when you say channels, that just implies
asynchronous channels
in my mind. Yeah. Well, fair enough. Fair enough. But they would probably want to be async, right? Or do you think they would be okay to be synchronous?
We'll see. I have a question actually, like from the audience, or to the audience rather. So we had this Spartan codec library before, and I've created Subspace codec. And I've also created Subspace archiving crate. However, we also have some extra extra functionality which should be shared between farmer and the node and maybe something else, which doesn't really fit either of those. For instance, we have tags that we need to check and some other pieces like signatures, and would like to have all of that in one crate. So I'm just wondering what I should call that crate. I want to pull Subspace codec and archiving into one. We can still call it Subspace archiving. We can call it Subspace farming or something like that. Like, what do you think would be the appropriate name for that? To put like everything, how to create pieces, how to encode pieces, how to validate pieces, how to validate tags and everything. So all of that functionality will be in there.
But that's also used on the client, right? That's validation as well. Okay, so that's like Subspace primitives, really, or like primitive functions almost.
Yes, we have Subspace core primitives, but that is more like data structures or like simple hash function. And those are working in both SCD and NoSCD environment. So this is something that can be compiled to WASM. This like archiving related thing is like more high level and more involved, and it's not compatible with NoSCD. So I think it should be separate. It's not as core. It's not like required to decode the message, but it is required to validate it. So I feel like it's slightly different. What do you think?
How about just Subspace pieces or pieces tools?
BP, yeah. Basically all the methods that would. Well, it's more than farming because it's, I don't know. I would say like Subspace consensus primitives.
We have all of those primitives already. We have a SP consensus POC, which will be a SP consensus Spartan, I think. Subspace, I think, eventually.
Yeah. I mean, I guess I would do it differently. So just whatever you prefer. I mean, from a protocol designer point of view, like farming is the farmer. So it's a little bit, I mean, the whole thing is farming, but we're calling the farmer farming,
That's why
so
I'm
it could be
trying.
confusing.
That's why I'm leaning towards farming, because we have an input, which is a block or an object, and then we do lots of stuff with it. We ratio code it, we create Tomoko trees, we create pieces, we plot pieces, we decode pieces, we validate pieces, we like create tags over them, we validate tags. Like everything is basically what farmer does. It's
Well,
all related
technically,
to archiving
technically
storage.
the farmer is only doing a subset of that. It's just the way you have it implemented right now. It's doing all that. A lot of that is done on the client. Actually, it's a consensus related thing. So it's farming is kind of a subset of that technically. Because the client has to the client has to know all this information as well.
It's still like a portion of the same like part of the protocol.
Because even if you're not, even if you're just a validator node or an executor, you would need all of this stuff as well, even if you weren't doing anything at all related with having a plot.
Well, yeah.
Maybe we call it like archival consensus or like something back with proofs of archival storage. Archiving primitives, maybe.
I don't feel like they are primitives. Maybe they are.
The whole thing is the prove verify challenge response like flow that you're dealing with. So you could call it maybe subspace prover.
It's not only prove verify, because prove verify is where when you already have a piece at least, and then you encode it, you decode it, and stuff like that. So the piece creation part is actually in Subspace archiving right now. It kind of belongs there. So maybe we just need to rename Spartan codec crate to something, and then we can add other things to it. Okay. I guess I'll have to figure it out myself.
Sorry, wish I could give you a better answer. Okay, so back to the question about exposing the farmer. I think that would be a great task for you to start working on Ozgun now that you're at a stopping point with the GPU article.
Okay.
I think maybe if you and Nazar just do a brief sync one-on-one, and you can explain what you're thinking here, Nazar.
Yeah, I will need some guidance, or at least some basic to-do list, something like that for refactoring.
I mean, the only other, sorry, go ahead, Nazar.
No.
Yeah, I mean, the other thing we could have you do, Ozgun, is start working on the Substrate Runtime Dev Academy course. That's going to take 1 to 2 weeks, I think, to realistically get through. But I feel like it would be better to have you really gain familiarity with the Farmer protocol and get better in Rust before jumping into Substrate, because it really does require a very good working knowledge of Rust to be effective.
Yeah, sounds great. Both worked for me.
Okay, let's do that. Let's focus on the Farmer. This initial task of refactoring it as a lib. And then I think, Nazar, you can probably try to piecemeal out some tasks to Ozgun as well that you've got on your to-do list. Okay. I think you and I, we'll talk about this in more detail after, Nazar, when we do a one-on-one sync. But I think I'm good right now for this call for the core protocol, unless there's anything else you guys want to discuss. Okay, great. Thanks for the update, Nazar. Thanks for all the hard work. It's really exciting to finally be at a V1. Serge, if you would like to give us an update on the relayer and let us know any questions or issues you've got right now.
Sure, let me share my screen. And yep. So I had this PR merge today. It's an update for pilot feeds, relatively small. I have added total objects and total size, which we use in the relayer UI. And let me show you what has changed in the code. So I have added this hash map called totals, and it stores structs with the property size and object, and we have each one for every feed ID. So feed ID is a key, and this struct is the value. And every time we put some object, we update this hash map by the given feed ID. So we basically add current object size to the total size, and we increment number of objects by 1. And we also included object size into the data submitted event. And yeah, when we create a feed, we basically insert the newly created feed ID into this hash map with default values, which are in this case zeros. Yeah, and that's it on my side.
Okay, and for the object count for a particular feed, or maybe the feed height, we're saying the nonce should be effectively the same thing right now?
It could be, but I think nonce increments anyway if every time we send transaction, but it may fail without like transaction can be sent, but it might not update the state of the chain. So I'm not sure there will always be the same values.
Okay, that makes sense.
Actually, I was exploring Polkadot.js yesterday around events, like why they decode incorrectly in our case. And I found that they actually have a way to submit a batch of different extrinsics as one. So, and I would imagine that will be one nonce for multiple things. So you might have something like a buffer of extrinsics for a particular chain which are ready to go. And once the previous one was confirmed, you can like set the batch of like 5 if it's enough.
Yeah, and it will also make it cheaper. So there will be less fee than if you would send individual extrinsics. And we need a palette utility for that.
It's cheaper because there's less overhead for the transaction?
Apparently.
Okay. I imagine that would be pretty small on the size of the transaction header versus the data that we're uploading, but still.
We can measure.
Yeah. Okay. So what are you seeing as next steps right now in the relayer palette or in feeds, Serge?
So in another branch, in my current branch with multiple accounts, I have also added palette proxy so we can use proxy accounts. Yeah, so but there I only updated our runtime, so we can use this palette. Nothing special there. And yeah, that branch is still in progress. I will continue working on that. Hopefully, everything will go well. And after that, I would like to spend some time implementing tests because we already have like a relatively big technical debt, I would say. Yeah, it's yeah, it would be safe to do some tests.
How many days do you expect it will take you to do the test coverage?
Well, I think we need like at least 2 days to spend on that. It won't be enough to cover everything, but at least something.
Okay. And so with the proxy accounts, so we are we setting up the accounts at Genesis, or are we creating transactions to set up all these accounts after the chain has been started?
Sorry, could you repeat? There was some.
Sorry, all the new accounts that we have, all these proxy accounts, those are created after Genesis, right? There's transactions that instantiate these accounts from the relayer.
No, we derive it without any transactions. We derive it without
Okay.
We have Alice account, and from Alice account we derive this chain specific accounts. And
so there's no account registration for proxy accounts. You just basically present it whenever you do the first transaction.
No, we need to make it, to add proxy, we need to submit an extrinsic to this proxy pilot. It's called add proxy.
So basically, yes, first time you send this like request.
And we also need to fund those accounts, so there will be like at least existential deposit.
And that's the problem that we're having right now. There's not an existential balance in them.
No, the problem right now that they're spending their own balances, not the balance from the master account.
Okay. So either there's a way to do that, or we have to actually fund these accounts from the master account, in which case there's really not any point in having proxy accounts. Might as well just be new accounts that we create.
Yeah, that is the worst case scenario. We just have to fund them or use one account.
Okay. Yeah,
there is still value in using multiple accounts, so we can send more transactions in parallel without having like any nonce issues.
Right. Okay, sounds good. And then I guess the other thing, a little bit off this call, but just with the relayer, just trying to get that deployed to a droplet so it's running continuously, the Node app.
Okay.
Just with its own, obviously right now with its own local version of Spartan until we get Subspace upgraded. So.
Okay. Who is responsible for droplets? Who can I contact to?
Do you have access to the DigitalOcean account right now?
I haven't checked yet, actually.
Okay,
just check that. Yeah, if no, I will contact Justin, right?
Yeah, Justin can give you access. I didn't realize that, but yeah, you've never needed to deploy anything, so you probably don't have an account there yet. But Justin can set you up with all that. Okay. And Leo's already got, he ran one that had the a node on it, so he's got like a template for that and everything pre-configured. You might just be able to clone that and then just add in the relayer into it. Okay. Okay. Any questions or comments on what Serge has been working on? All right. I want to give you guys an update on just what I'm thinking right now regarding the protocol. So Nazar and I still need to sync up one-on-one and try to sort out some of the more concrete next steps. And this is going to be a big part of what we're going to talk about at the engineering offsite as well. But very high level, what I would like to do over the next couple of weeks, maybe 6 weeks, is I would like to Ozgun have you get more integrated into the farmer and start getting through this backlog of tasks we have there. Nazar, obviously we've got a lot of to-dos here with Subspace to make it more robust, get it up to a V1. And then Serge, I think Relayer is coming to a stopping point. Some of the big things are going to be getting it to do the pre-Genesis data. So I guess let me paint the picture of what I'd like to see. I don't know how long this is going to take. This might take 2 weeks. It might take 6 weeks to get there. But what I'd like to see from a big picture perspective is that we have our testnet running Subspace consensus. The Genesis data is going to be the current the current history of Kusama and all the parachains. So everything that we have in the Relayer app, okay, like up to whenever we start the testnet, all that data is stored somewhere. Maybe for now we just store it, you know, on a DO droplet or in a volume somewhere. And that data, it would be whenever we start the testnet node, it's going to pull from that data source and do this pre-Genesis object inclusion. And then we're gonna have a farmer running, which will be using this new lib version of the farmer. And that farmer will create this plot up to the size of the history. And then as new blocks are coming in, it will incrementally plot those blocks and update them in, update the commitments and basically be able to use them immediately for farming. And that will be live on our testnet. And then anybody who spins up a farmer will basically first sync the history and in this sort of naive fashion and plot. And then just join the consensus. So the plots of the nodes on the network will basically be the size of the expanded history. Okay, so it's not like you can configure your size yet. So that way we will have effectively a storage network where every node is a full node. Every farmer has a full copy of the erasure coded expanded blockchain. So something that kind of looks like the way Arweave works, basically. It's just that we're using that data for consensus directly versus doing some proof of work over it. The other big part of this is Subspace.js, okay? We've got this put workflow, which we've got working through the relayer. We don't have a get workflow yet. So I would like to have some baseline get workflow. It's not going to use the DHT. It's not going to do any of the fancy stuff we're hoping for. It should just be simply given an object ID, connect to any farmer on the network and retrieve, or sorry, given the, yeah, I guess we do need the table actually. Yeah, we want to be able to given the object ID, retrieve. So there's two things really. There's given a piece index. That's the first thing we have to do. Given a piece index, connect to a farmer, retrieve the piece, retrieve the encoding, be able to decode and get the piece back out. The second thing is going to be given an object ID, retrieve the object. So that means probably to start, we're gonna have like a full object ID table on each farmer, which I know is not gonna scale and not gonna be efficient, but it will at least give us retrievability. So that means that we can then define the external API, which will initially be in JavaScript, for puts and gets, and hopefully once we define that API will hopefully never change. I'm sure it will change some, but it's not going to change drastically. Then we can refactor the guts internally, you know, as we upgrade to distributed farming and we do all these other great things we have planned. From the external point of view, it's still, well, I put data in and I get an object ID out, and I call an object ID and I get data out. It still looks the same. Or I call a piece and I get an encoding that I decode back out. So just that very, very basic functionality. Go ahead, Nazar.
There is still like a challenge. You don't have a mechanism how to map the object to where it's actually in the history when it's turned into pieces. Or rather we actually need to map it somehow into segment, I think, because the particular piece you're looking for might be missing, but you might be able to reconstruct it. So you need to know where it's actually located within pre-erasure coded segment and then figure out what pieces you actually need for that. And we don't have any mechanisms to map like this transaction starts here and this transaction starts here and this is where the data is located. So this is like a separate project how to create this mapping in the first place.
Yeah, no, you're absolutely right. And probably like we'll start with just retrieving the pieces by index and get that basic network API working. And then the next step is, you're correct. As soon as when we archive blocks, we have to, as part of whatever we announce, when we announce the archiving event, we need to include basically a vec of these entries, which say for this object ID, this is the segment or the piece index where it starts. This is the offset in the piece, and then this is the basically the length of the data to read. And then we can construct we can use that retrieve piece API or method to construct a retrieve object. I think to start, it doesn't need to work in the notion of erasure coding because we're going to assume everybody's a full replica. We can eventually extend it so that it can, compile, erasure coded pieces and non-erasure coded pieces, and if necessary, reconstruct the entire thing. I think that's more of an optimization as we get more into the distributed storage network. But I guess my point with this, the reason that we would like to get to this is because this gives us a developer storage API where we can start building things that are like NFT metadata storage, or we can start building like these more interesting applications that people are always talking to us about on regarding Subspace and its use cases. And I think if we can, even if it's not working the way that we intend it to on the back end, as long as from the front end it has the same perspective, that's a lot more interesting to developers, and we're able to actually like show working applications, be like, well, it's not fully distributed yet, but it will be soon. But the developer interface is more or less unchanged. And that's kind of the next big step. Like relayer archiving was sort of the first big step, right? The next one is going to be this retrievability workflow or this object put, object get workflow. And then we've got a whole lot of work to do on making it really distributed and efficient and durable and load balance and all these other things that we have planned. But I think we can get to a useful version of it much sooner than that. Okay. Any questions on that? Okay. All right. Any questions in general or comments before we close out? Okay, I'm going to stop recording. Thanks everybody for watching.